Good morning, students. We're going to now multiply and divide monomials. Monomial, remember, means one. So we only have one term in the polynomial. Remember, monomial is one of the many polynomials. So we only have one term here. Remember, terms are separated by plus or minus signs. So there is no plus or minus signs here. It's all one term, the entire thing here. Now, the key in remembering with multiplying monomials or polynomials is, first off, this a, the variable, is called the base, okay? And the number in the numerator is called the exponent. So when we have like bases, in this case, like, also, you often just think like variables, the same variable, and we multiply them together, we add in multiplication of polynomials add the exponents of like bases. Okay, the base stays the same, we just add the exponents. All right, so I'm going to do odds again. So let's do number 5. I have a C there and a C there. So those are like bases. So I put down the C. I add the exponents. Remember, if there's nothing there, there's a 1. So I have a 1 plus a 3. That to me looks like 3. So 1 plus 3 is 4. Then I have another like base, D. So D. I have 2 D's there and 2 D's there. 2 plus 2 is 4. So all this is your ability to add your exponents on the same variable correctly. Okay. Now we also have, let me pick one that's, I'm trying to find one like 6 in the odds. Okay, 19 right here. So there we have a 2 on the outside. That means take 2e over 3 times 2e over 3, because it says twice. I mean squared. So we don't, you can say to the second power. That's the longest way of saying it. The shortest way of saying it is saying squared. So you get used to saying squared. Okay, which ultimately means that you're distributing the 2 through every piece inside of there. So you can either do it like that or write it out, 2e over 3 times 2e over 3, and then multiply those together. In the numerator, 2 times 2 is 4. We have an e for the base. Remember, that exponent is 1 and that exponent is 1 when there's nothing there. What's 1 plus 1? 2. And then in the denominator, we have 3 times 3 is 9. Nothing simplifies. Otherwise, we would have to do that. So there's just our final answer right there. Okay. So if you weren't to write it out like that, the other way is to distribute the 2 through there. And so you write 2 squared e squared over 3 squared, distributing that 2 through there. And then I would get the same answer, 4e squared over 9. So you can do it either of those two ways. Okay. Now, let's see another odd one here. That's, all right, number 33. Notice that's a 2 outside there, so I have to distribute this exponent of 2 for each of those. Again, I could rewrite it out, 0.2a squared b cubed, 0.2a squared b cubed times 0.2a squared b cubed. I could write it out if I needed to, if that's easier for you to do. Or I make sure I draw my arrows like that to distribute through every piece inside the parentheses. So 0.2 squared, 0.2 times 0.2. Okay, what's 2 times 2? 4. But then I have one number to the right of the decimal, and I'd have it again. So now I have a total of 2 to the right of the decimal. So I have to have 2 decimal points over. So it's 0.04. 0.2 times 0.2 is 0.04. a squared squared. There's my a squared right there. A squared squared a. I add my exponents. 2 plus 2 is 4. My base of b right there. 3 plus 3 is 6. So if I was to do it this way, I have b cubed squared. You remember your exponent rules. A power to a power. This is a power. Another word for exponent is power. This power is to another power. So this is called a power to a power rule. The power to the power rule means you multiply your exponents. And that's why 3 times 2 is 6, which is what we have right there, b to the 6th. So if you are not good at remembering your power rules, then you should write it out like this, and then you can just add your exponents, okay, to get that final answer for that right there. But if you remember your power rules, which is obviously what you'd want to do for extra credit for speed, okay, power to power, you multiply. Okay, so there is our final answer right there. Okay, now division. Remember, multiplication on the other side, we added the exponents of like bases. In division, we subtract the exponents of like bases. So number 1, this would be c, that's 0, it looks like 0 minus, and that looks like a minus, I'll say minus 5. I can't read it right now from there. So 0 minus a minus 5 is, change that to a plus, so that'd be c to the 5th power. Okay. The reason it says assume that no denominator is equal to 0 is because you cannot divide by 0. You can never have 0 in the denominator. You should know that already. Okay, that's one of the rules. You can't have a 0 in the denominator, and you can't have a radical in the denominator. Okay, now, let's deal with number 2, because I don't see another one right just like that. Number 2, notice it says 1 over x to the negative 4, I believe. How do I make a negative exponent positive? I move it up. That's called the reciprocal. Okay, so I have a negative exponent in the denominator. To make it positive, it must go up to the numerator. So that really just says 1x to the 4th. And there's my answer. Okay, we always want to have our final answer with positive exponents. So I would not leave it as 1 over x to the negative 4, even though that equals this. Usually they always want you to write it as positive exponents. Okay, so let's look at 7. I have 9 divided by 3 is just 3. Like bases are d, and I subtract them. 7 minus, dang, what number is it? 2. Let's say that's a 2. 7 minus 2 is 5. And I don't write the over 1. Anything divided by 1 is itself. So the answer is 3d to the 5th. Okay? Sure hope these exponents come out clear on your worksheet than when they came out to this right here, the smart notebook. I'll blow it up so make sure that we can read them on your worksheet on the screen here. Okay, let's take another odd one right here, Okay, so it says 15 divided by negative 3, that'd be negative 5 in the numerator. Here I have a plus, I think it's a 2, but then for the x down here, I have a minus 5. So I have like basis of x, but I'm doing 2 minus negative 5. Okay, then I have y, and that looks like it. We'll go with, dang, I can't even read that. It may not be what it is here. We'll just say 3 and 6. I'll just put those in there. Doesn't matter, it's the rules. Okay, that we're working on here. So that'd be 3 minus 6. So when I do that, now I have negative 5, which is 2 minus a minus 5, 7, x to the 7th, and y, 3 minus 6 would be negative 3. Now, remember, I just got into telling you, so that is a true statement right there, but remember, we want to write it as positive exponents. So this is already positive right there, so it stays in the numerator. 5x to the 7th, but remember this is a negative. So in order to make it positive, I need to drop it down to the denominator, the reciprocal, and therefore there's my final answer with all positive exponents. And that's likely what they're going to ask you on the DCAS as well, unless they give you a multiple choice to see if you can rearrange the positives and negatives, and they give you all different versions, and they have both of these down and say all, circle all the ones or choose all the ones that are the same value. Obviously, those are the exact same value right there. Okay. The other way is if you wanted to, do I see any more of those practice ones with negatives? Make sure you're finding the like variable, like base, before you do your subtraction of your exponents. Remember, if there's nothing on it, it's always a 1. Okay? So you can write those 1s in there so you don't forget. That's a common error that beginning students forget. Algebra 1 students forget. They forget that there's 1s there. They think of them as zeros. So do not forget. There's no variable, no exponent on the variable. It's always a 1. So write it in there until it becomes automatic in your head that that's a 1. Let me make up a different one to show you a different way. Let's say I have 2x to the 4th over x to the negative 3. I could subtract down and do 4 minus a minus 3 and get 7. But the other way is to always just change the negatives to a positive. So how do I change that negative exponent to a positive? I move it up there. So now it'd be 2x to the 4th times x cubed. And then that'd be like the front page. We're doing multiply like bases. Base stays the same. We just add the exponents. 4 plus 3 is 7. So that's the other way, is to just move your negative exponents from wherever it was, in this case the denominator, up to the numerator. Or if you started with a negative, 2x to negative 1 over x to negative 3, okay, to make this one positive, it goes down. To make this one positive, it goes up. And I'd have 2x cubed over x to the 1st. Now, for a lot of people, it's much easier to subtract whole numbers because now that's from elementary school, 2nd grade on. So now I have 2x and 3 minus 1 is 2. See, some people would blow this one over here, and it should be x negative 1 minus a minus 3. But they don't always remember to do minus a minus 3. And now I'd have 3 minus 1 is 2. And so I still get the same answer. But for a lot of people, and I often do this myself, is I change all the negatives to positives, like I did here, and then subtract to get that final answer. Okay, so that's just another side note on a different way of, do it. You don't always have to subtract. You can change the negatives to positives by moving it to the numerator or down to the denominator, and then just do your regular multiplication way, okay, or subtraction if they're in both. But then you're only subtracting whole numbers, much easier. Okay, that goes ahead and ends this video.